Hello everyone and welcome to PE Academy. So in this video we are going to be looking at Supermesh. So in the previous video we've looked at mesh analysis and now we are going to be looking at Supermesh. So now when we talk about Supermesh is used to solve a circuit whereby we have a current source between two loops. Now let me note that down. So I say Supermesh is used so when there is a current source between two meshes. Is it meshes or mesh? All right, so when there is a current source between two mesh, that is when we use Supermesh. And if you remember when we look at mesh analysis, if just in case you missed that video, you can check the description of this video. You see a playlist to the videos I've done under mesh analysis. Now if you come across some question under mesh analysis, you discover that you might not be able to solve them when there is a current between two different mesh. So I might be using the word mesh and loops interchangeably. In this case they are similar, although they are different. You can also check the playlist for a video I did talking about the difference between a mesh, loop, branch, element, and all those things. So now let's continue. Supermesh, I said what it is used when there is a current source between two meshes. Now let's examine this circuit. So we are going to be using this. I'm going to be using this circuit to explain the concept of Supermesh, and I'm very sure at the end of this video you'll be able to solve any question under mesh, Supermesh, using Supermesh analysis. So this is what makes it a super mesh. So you can see in this diagram we are having what? A current source in between two mesh. You know, if you have to solve this using ordinary mesh analysis, you might not be able to, you'll not be able to do it just because of this current source in between. So that is where the idea of super mesh comes into place. Now let me put in some values. Let's call this is our resistor, let's call it R1, and then let's call this R2, and let's call this R3. So this is our voltage source. Let's just give it, that's V. And let's say in this question we are asked to find the current that is flowing through the R1, the current flowing through R2, and the current flowing through the R3, the three resistors, using what? Using Supermesh. So just like we do when we are solving mesh analysis, you pick your current direction for the three meshes that we are having here. So let's take a clockwise direction. If you are following my mesh solution, you notice that I mostly use clockwise direction. So in clockwise direction, let's call this I1. This is I2, and then all right. So let me just use this as I3, and let me use this as I2. You can use anything, you can interchange them, you still get the same answer. So once we do this, the next thing we do, using the idea or the concept of we go from mesh analysis. So let's add the polarities in this direction. So don't forget the polarity of the voltage source is constant. The longer side is the positive and this is the negative. So but for the elements like the resistor we are having there, we are going to be giving it polarities based on the direction of the current. So for this I1, this is going to be plus, minus. So that's it. Let's come for this I3, this will be plus and this will be minus. And then for this particular mesh where we are having I2, in this direction this is going to be plus, minus. We are going to be having plus, minus, plus, minus. I want to believe by now you are familiar with what I've just done here. If you are not, probably you missed the video on mesh analysis and I want you to watch that. Alright, so after you have done this, don't forget this is a circuit you are trying to solve using Supermesh. The question is saying that we should look for the value of I1, the current through each of the three resistors. Alright, so what you do now is, you see this one where we are having the current source that is between two meshes, you are going to have what we call the equation of the current source. Now let me draw that one out. So let me use this space. So what we are having here, this is it here that I've just drawn out. Now if you look at from what we are having here, there are two currents that is flowing through this current source. We have this I3 current and this I1 current, and they are moving in this direction. Following this direction, that means we are going to be having something like this. in clockwise direction, this is what? I1. And then we're also going to be having another one like this, which is I3. This I3, this is it. So that means we have two current that is flowing through this current source, this one that we are having here. Now for us to write the equation of the current source, let me write it here. I hope you can see it. Equation of current source. So the equation of current source is, now if you look at this diagram closely, you see that I3 is in direction with the current source itself. The current source is going upward, and in this direction, the one that is going upward is I3, compared to I1, also in clockwise direction, but it is coming downward when you are looking at it with the current source. So what that means is that whichever one that is in the same direction with the current source will come first. So that will give us I3 minus I1. I3 minus I1 equals to I. So what this means is that I3 minus 1, that means the current I3 is more than I1 because they are flowing in the same direction. I3 is in the same direction with the current source compared to what? To I1. I1 is in opposite direction. You can see this is going upward, and while I1, current I1 is coming downward. So this is the equation. So if in more examples, we are going to be seeing more of this. So just note this. This we are going to refer to it as our equation 1. So if you are finding value in this video, please give it a thumbs up. So now we've been able to get one of the equations that we need. So the next thing we are going to do, this is more like the step 1 in solving questions under Supermesh. Now let's look at the next thing we are going to do is, you look at that that particular loops that we are having this current source in between. You are going to redraw it. So we are going to draw the mesh that is showing the current source without the current source itself. This is what I'm talking about. So we are going to be redrawing this circuit, just this part. So we are going to be having something like this. We are going to be having something like this. So let's bring in the elements. This is R2, this is R3. So now we are not going to be putting the current source. We are going to put in every other thing. This is positive, this is negative, this is the voltage source. And for the polarities here, we have towards this direction, we have our I1. If you look at it here, in this direction, for this R2 is flowing towards this direction, that is I1. If you look at R3, in this direction, we have I3 flowing in that direction. You have I3 flowing in that direction, yes. So let's look at it at the top. And then let's also add our polarities. The polarities in this direction, this is plus, minus, and this is plus and minus. Then for I2 in this particular resistor is flowing in this direction. So the polarity will be plus and minus here. And then we also have I2 flowing in this direction. We also have I2 flowing in this direction, and also I2 flowing in this direction. This is I2, and then the polarity will be plus and minus. So with what we've just drawn here, we are going to apply KVL. That's Kirchhoff voltage law. Just now we are going to take this like the same way we are solving not mesh circuits. That's what we are going to follow here. So we are going to start from one of the node straight down to the same node. So let's say we are starting from here. If you are picking if you go around the circuit, also in a clockwise direction. So we are going to apply KVL. In doing that, if you are starting from here, going in this direction, so this is negative to positive. That means we are going to be having V, right? Then from here, we come here to this resistor R2. Now, because of the current I1 that is flowing it in this direction, you can see this is the direction here. That is going to be what? Remember, V is equals to IR. That is the current times the resistance. So because of this direction, which is going from positive to negative, that's going to give us minus I1 R2, like this. Now there's also another current coming the other way from left to right. I hope from my screen from left to right, current I2 is coming in this direction. So that's going to be, this is negative, positive. So that's going to be plus I2 R2. So we are done with this. Now let's go to the next one. From positive to negative due to current I3 for this particular element or resistor R3. So that's going to give us minus I3 R3. Now for this other current I2 that is flowing through this resistor, this is from plus to minus. That's going to be, sorry, from minus to plus rather. So that's going to be plus I2 R3. Then we come back to the voltage, so there's nothing there. That's all equals to what? To 0. If this is not clear to you, just pause the video, you watch it slowly or watch it again, or just follow along. We are still going to be using real numbers. Now I'm using alphabet just to give you an idea of how Supermesh works. So now let's simplify what we are having here. So here we are going to be having V. So if you look at what is common here, we have R2, V minus R2 into brackets I1 minus I2. Because by the time we open this bracket, this is minus. If you open this bracket, we are going to be having this. And then here we also have R3 to be common. We are going to be having minus R3 into brackets I3 minus I2 equals to 0. So with that, now we can have our V to be, when it comes to the other side of the equals to sign, R2 into brackets I1 minus I2 plus R3 into brackets I3 minus I2. And this is here is equation 2. And here is equation 2. And this equation 2 is when we put these two mesh together. Now, we are now going to look at this mesh 3. I mean this mesh with this mesh with I2, current flowing through it. Now this itself is just a mesh. We are going to apply mesh analysis for this particular one, because this is where the super mesh comes into place. This is where we apply super mesh. So I want you to hold on to that whenever you are solving questions under super mesh. So this is the only part where we apply super mesh, where the current source is being shared between two mesh. Where there is a current source between two mesh, that's where we apply super mesh. So every other mesh where there is no current source being shared between two meshes, we just apply mesh. So now let's do that to this mesh. So let's call this mesh 2. So let's say for mesh 2. So let me just, so that I can separate it. If you are finding value in this video, please give it a thumbs up. Alright, so for this mesh, now let's just start from this point, from this node here, and go around the circuit. Alright, so if you should go here, this is the first thing we are coming across. This is from plus to minus and current I2. That's going to give us minus I2 R1. So if you should continue again, we get here and then we come here. When we get here, from positive to negative, and that is the current I2 flowing from positive to negative in elements in this resistor R3. So we are going to be having minus I2 R3. Also in this same resistor, we have, due to current I3 flowing through it from positive to negative, that is going to be plus I3 R3. We've done something like this when we are looking at mesh, so don't let it to confuse you. So we are done with this element. Let's go to this. If in this same direction, from positive to negative due to current I2, so that's going to give us minus I2 R2. From negative to positive due to the current I1, so that's going to give us plus I1 R2, because in this resistor we are having two current that are flowing through it. We have current I1 and current I2 flowing through. So all these things we put into consideration when we are simplifying it. Then we come back to the node where we started from. There's no other thing. Then we can say equals to 0. So now let's simplify this that we are having here. So let's look at it closely so that we can just collect some like terms. So in collecting like terms, we are going to be having this I3 R3. So let me bring it first. We are having I3 R3 plus I1 R2. Now if you look at this that we are having here, let me underline it. This and this. You see that they have one thing in common. That is minus I2. So I can bring that outside and have minus I2 into brackets R1, that is for this, minus I2, we have R3 here. So we are going to be having plus R3, and then for this we also have minus I2. So we are going to be having plus R2, all equals to 0. Now, what we are having here is our equation 3. Like I said earlier, if it's looking confusing, Supermesh is not difficult. If what I've just done is looking confusing, I want to believe it's because we are using alphabet. In the next example, I'm going to be using real numbers, which will give you more understanding on how to solve questions under Supermesh. So this concept is not difficult at all. Now, for us to get the current flowing through each of these resistors, that is the R1, R2, and R3. By the time you solve equation 1, this equation 1, equation 2, and equation 3, by the time you solve them simultaneously, you get your value, the value of Ri, the current in each of those resistors. So once you solve them simultaneously, you get the answer. So I want to believe this has given you a foundation on Supermesh. In the next examples, I have like 5 different examples I'm going to be showing you on how to solve Supermesh. So in the next example, I'm going to be showing you different examples that will guide you on how to solve any questions when you are asked to solve Supermesh. And it's also important to know that if you are solving all of these questions under circuit analysis, mesh, supermesh, node analysis, it's important to know all of this method, because some questions can ask you categorically that use this method, use this other method. Because for example, this particular question we are having here, we can use other method to solve it, like node analysis. There's also a video on that. You can check the description of this video. You can ask you to use node analysis to solve this question. So, but some can tell you use supermesh. So it's important to know all of this different method of solving or analyzing circuit. So I want to believe you find value in this video. If you do, please give it a thumbs up, and with that I'll see you all in the next video, which is going to be example 1 under Supermesh.